Welcome to Ask and Learn.
In this problem, we have a paddle wheel in an oxygen tank which is rotated until the pressure inside rises to 20 psi, while some heat is lost to the surroundings. We need to calculate the work done by the paddle wheel. Now we assume that oxygen is an ideal gas in this problem. The kinetic and potential energy changes are negligible, and the energy stored in the paddle wheel is negligible. So also the volume remains constant. Now the gas constant of oxygen, R, is equal to 0.3353 pounds per square inch absolute foot cubed per pound mass R. And the molar mass of oxygen, M, is equal to 32, and that's pound mass per pound mole. So the specific heat of oxygen at average temperature, which is the average of the final and initial state temperatures, is 735 plus 540 over 2, and this is 638 R. And at this temperature, the specific heat at constant volume, C, from our tables, is 0.16 BTU per pound mass R. So now we have our properties of our system, and since the system is closed, we can write our energy balance equation, which is E in, the energy in minus the energy out, must equal to the change of the energy of the system. And the energy in is due to the work done by the paddle wheel, so we call that W, and the energy out is due to the heat loss to the surroundings, and this must be equal to the internal energy change delta U for the system. So we wish to calculate the work done by the paddle wheel into the system, and this is equal to Q out, which is the heat out, plus M into U2 minus U1. So that's M times CV times the change in temperature, T2 minus T1. So there we have our energy balance equation, and we've rearranged it to solve for the work done by the paddle wheel. Now, the final temperature of the final temperature of the oxygen and the mass of oxygen can be calculated as follows. So for the temperature, we'll use the ideal gas relation P1V over T1 is equal to P2V over T2. And so we can rearrange this equation and find the final temperature. T2 is equal to P2 over P1 times T1. And these values are all known. So that's 20 psi over 14.7 psi times 540 R for T1. And so we get T2 to be 735 R. Now the mass of oxygen, M, is equal to P1 times V over R T1, again using ideal gas equations. So this is 14.7 psi into 10 cubic feet, which is the volume, over R, which we showed is 0.3353, that's psi foot cube per pound mole R, multiplied by the temperature T1, which is 540 R. And so we get our mass of oxygen in pounds to be 0.812. Now that we have the mass and temperature, we can go back to the energy balance equation and calculate the work done by the paddle wheel. So the work done by the paddle wheel into the system is equal to 20 BTU plus 0.812 pounds, that's M, into 0.160 BTU per pound mass R, and that's multiplied by the temperature change of 735 minus 540 R. And so we get the work done by the paddle wheel to be 45.3 BTU.